This video is for Integrated 3. This is on the Chapter 2 Pear Deck Graphing Parent Functions Practice. And all of these problems are practice for you guys to get ready for our Chapter 2 tests, doing all the graphing. That's usually the difficulty people have. So this is a Pear Deck Google slide if you haven't used one before. And this is interactive. So you're going to be able to draw on the screens. Down here is the pencil. It's actually all of these colors you can pick, so I wouldn't really call it a pencil, more like a pen. This is a highlighter. This draws lines. This is text, but we're really not going to need to necessarily type on this. And then this is your eraser. And here is an undo. Okay, you can undo. I would recommend moving your cursor down when you're drawing because it can be pretty big. So I would have it down all the way at the bottom. I'm going to have mine a little bit more when I'm doing my points just so you can follow them if you're following along with this video. So on this, what I'm going to do first, I'm going to drag that down. Okay, make that a little smaller. Pick whatever color I want. Okay. And then what I'm going to do is I'm first going to identify where my vertex for this parabola is. And my vertex is going to be at 0, 3. So I am going to go to 0, 3. And what I'm going to do is put a point there. That's going to be my vertex. And then from here, it's a regular parabola. So I can just think of it as go out 1, 1 squared is 1. So I'm going to go up 1 on both sides. Go out 2, 2 squared is 4. So I'm going to go up 4, 1, 2, 3, 4. Out 3, 3 squared is 9. So I'm going to go up 9. So that's 4, 5, 6, 7, 8, 9. And then I am going to connect this. And there's my parabola. On this one, this is a cubic graph. It has an inflection point at 0, -1. So let me plot that. So I'm going to go to 0, -1. Okay, that's my inflection point. And then let me graph the other ones in a different color because that's my inflection point. So from there, I'm going to go out 1. 1 cubed is 1. So I go up 1. From here, I go out 2. 2 cubed is 8. So I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. Now I would go out 3. That would be 27. That's not going to fit. I'm going to come back to my inflection point. I'm going to go over 1. This is -1. I'm going -1. -1 cubed is -1. Okay, go back here, go out 2, -2. -2 cubed is -8. So 1, 2, 3, 4, 5, 6, 7, 8. Then I am going to connect these and have my cubic graph. Just going to undo that. And there's my graph. On this one is a parabola. My vertex is going to be 4, 0, and it has a regular stretch. So I am going to go to 4, 0, and then from there, it's a regular parabola. So 1, go out 1, 1 squared is 1. Okay. Go out 2, 2 squared is 4. So 1, 2, 3, 4. Same on the other side. I am going to go to 3, 1, 2, 3. 3 squared is 9. So that's going to be right here. And then I'm going to connect this. And there is my parabola. This one is an absolute value graph, and whatever makes my absolute value 0, which is going to be a -3, that's going to be the x-coordinate, and then it's going to be 0 because I don't have anything outside of that. So I'm going to go to -3, 0, and put my vertex. Now there's no stretch here, so you can really think of it as a 1. And since these are linear in nature, you can really think of this as a slope, up 1 over 1, up 1 over 1. So here, let me grab this one more time, sorry. Up 1 over 1, up 1 over 1. Okay, same in the other direction, up 1 over 1, up 1 over 1. Now I can use this line tool if I want and connect it with the line. And there is my absolute value graph. This one is a square root. And my square root is going to start at 2, because that's what makes the square root 0, comma 1. And what this is a half of a sideways parabola. So I am going to go to 2 comma 1, put a point there. And then from here, I'm going to go out certain amounts from here and take the square root of that. So if I go out 1, take the square root of 1, 1. So I'm going to go up 1. If I go out 2, square root of 2 is not nice. If I go out 3, square root of 3 is not nice. So the next one's going to be square root of 4. 1, 2, 3, 4. And the square root of 4 is 2. The next nice one's going to be 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And the square root of 9 is 3. 1, 2, 3. That was 9, 16. So 10, 11, 12, 13, 14, 15, 16. And the square root of 16 is 4. So 1, 2, 3, 4. And then I'm going to have my graph. And that's my square root. This one is a parabola. It's going to be an upside down parabola because of that. And my vertex is going to be -2, -1. So I'm going to go to -2, -1. -2, -1. And then it is going to open down. So let me move this. It has a stretch of, let me just undo that. So is okay. So it is going to have a stretch of -1. So again, it was at -2, -1. And then from here, 1 squared is 1, times it by -1. 2 squared is 4, times it by -1. 1, 2, 3, 4. 3 squared, 1, 2, 3 is 9, times that by -1. I'm going to go -9. So 4, 5, 6, 7, 8, 9. And then I'm going to connect this, and I have my open down parabola. Okay, next one is a reciprocal function. I am going to have, I'm going to use a highlighter here. I'm going to have 2 asymptotes. One of them is going to be at x equals 0. And that is going to be a vertical line right here, x equals 0. The other one is going to be y equals 0. That's going to be a horizontal line right here. So y equals 0. And then what I want to think of is I want to think of basically, if I was to rewrite this, this is xy equal 1. So I want things that multiply to 1. So the only nice point I really need from us is going to be 1 comma 1, because if I go out 1, 1 times 1 is 1. Now I could go out 2, 2 times a half if I want, okay? I could go a half, 1/2 times 2 if I want, but the one I need from you guys is this one right here. Now I also am gonna need -1 times -1, so I'm gonna also need that point, okay? So let me just get rid of that. Let me just undo it. Okay. So I have that one right there and that one there. Then what I'm going to do is it is going to be a curve and another curve, and that is our graph. Now this one is going to have an asymptote at x equals 0. Sorry, not 0, x equal 2. So let me start over on this problem. This problem has a vertical asymptote at x equal 2 because that would make our denominator 0. It has a horizontal asymptote at y equal 4 because of that plus 4. So my x equal 2, let me draw that in. And I kind of think of this as almost like the new xy axes. And sorry, I don't know why I keep doing that. Okay. X equal 2. Okay, so then we have y equal 4. Now, if I was to think about a locator point, I guess a locator point would be 2, 4. I'm just going to temporarily put it here. That's 2, 4. That point is not on our graph, but it is kind of like our new center. Okay, so let me see if it will undo that for me. Okay. And then when I'm looking at this and I see that this is a 1, then I want things that multiply to 1. So I am going to have a point that is going to be 1 away from my asymptote and up 1. And same here, 1 away, down 1, because that would be like 1 times 1 and -1 times -1. And then I'm going to draw my curve. Okay, again, that point there. And that's my graph. Reciprocal function. This one is an exponential graph. And for this, it's going to have a horizontal asymptote at y equals 0. So let me draw that in. And for this, I basically have a regular exponential with a base of 2. So I'm really having something that's growing by 2, doubling each time. So I'm going to start here at 0, and 2 to the 0 is 1. So that's my y-intercept. That's always my starting value, no matter where this is being moved. Even if it's not my y-intercept, it's the starting one I'm going to do, even if the graph gets moved. And then this would be 2 to the first, which is 2. Okay, this would be 2 to the second, which is 4. 2 to the third, which is 8. And the way I really think about it, when you have a base of 2, you're doubling. So my first height is a away, but in this case, we don't have an a in front, so our a is really 1. So 2 to the 0 is 1. That's where I'm going to start. And then that's 1 high. I double 1, I get 2. 2 high, I double 2, I get 4. I double 4, I get 8. I double 8, I get 16, and so forth. And then let me draw that. I have an increasing or exponential growth problem here. Okay, the next one, another exponential. This exponential is going to be moving to the left one. So if you wanted to think about kind of a locator point, it would be -1 comma 0. And I do have a horizontal asymptote at y equals 0. Okay, so I'm going to have that drawn in here at y equals 0. And I'm just going to put a point temporarily at -1, 0. That point that I just put there is not on my graph, but that's kind of like where I'm going to start. Okay, so normally I would have started here and done 2 to the 0. This is kind of going to be where my start is. Okay, so what I'm going to be doing, I'm going to be starting here at -1, and this is where I'm going to do 2 to the 0, because this is my starting. 2 to the 0 is 1. Oops, that's maybe a little too fat. Let me undo that. Okay. Okay, so I'm going to be starting at -1, and I'm going to do 2 to the 0, which is 1. And if I go over 1, 2 to the first is 2. 2 squared is 4. But again, I think about this first one's going to be 1 high. Then I'm doubling 2 high. Then I'm doubling 4. Then the next one's going to be 8. The next one's going to be 16, and so forth. And then I'm going to connect this. And there is my exponential graph. Another exponential graph. This one has a locator point at 3 comma 4. And what I'm going to be concerned with is my asymptote is going to be at y equal 4 because of that plus 4. So let me draw that in. And now what I'm going to do is, again, that locator point, make this a little thicker. That locator point is going to be at 1, 2, well, 3 comma 4, which is going to be right here. So this is where I'm going to start. This is where I'm going to go 2 to the 0, which is 1. Okay. So that's always my A away. In this case, 1 away because my A is 1. But it's also 2 to the 0, which is 1. 2 to the first is 2. 2 to the second is 4. But again, I'm doubling 1, 2, 4, 5, 6, 7, 8. And then I can connect my points. And there's my graph. This is another exponential. I can think of the locator point as -4, -3. So I'm going to have an asymptote down at -3. So let me draw that in. And then again, my locator point is going to be at -4, -3. So -4, -3. So really the way I think about it is I go to my asymptote, which is going to the -3, and then I go to the left 1, 2, 3, 4. Okay. And this is where I'm going to start. So 2 to the 0 is 1. My next height's going to be 2. My next height's 4. Next height is going to be 6, 7, 8. Whoops, I forgot my so 1, 2, 4, 8. So 5, 6, 7, 8. And then I can connect it. And this is going to be my graph. This one is going to be an absolute value graph with a vertex of 2 comma -1. So I'm going to go to 2 comma -1, 2 -1. That's going to be my start. Now this has a stretch of 1/3, but since this is linear, you can think of it as a slope only for these ones, not for any other type of these of graph, just for these absolute values. Up 1 over 3. Up 1 over 3. Let me do it one more. Up 1 over 3. Now I'm going to do the same on the other side. Up 1 over 3, up 1 over 3, up 1 over 3. I'm going to use the line, make sure that it's thin, and there you go. There is our absolute value. This graph is a parabola. It's going to be an open down parabola with a stretch of -2. And my vertex is going to be at -3, 4. So that's where I'm going to start, is at -3, 4. So -3, 4. And then this is going to open down. So I'm going to go over 1. 1 squared is 1, double that. So and make it negative. So I go down to -2. I go out 2, 2 squared is 4, double that. Basically, I'm timesing it by -2. So it's going to be -8. So 1, 2, 3, 4, 5, 6, 7, 8. So I'm doubling 1 squared. After I square it, I double it. I'm doubling 2 squared, which is 4. I double that 4, I get a -8. Okay, so you're going to square and then double. And I get my sorry, I was just going to get this to be okay. Try it one more time. And this one I put here in the wrong spot. Okay. So this one should have been right there. And then I can connect my points, and there's my graph. This one is a cubic. It's going to have a locator point and an inflection point at 4, 1. I'm going to do that point in a different color just so we can see it. So 4, 1, that is my locator point. Okay. And then let me plot all the other ones. Now what I need to see here is this is not going to be just 1 cubed is 1 and 2 cubed is 8. I have a stretch of 2. So I'm going to double after I cube. So I go over 1, 1 cubed is 1, times that by 2, 2. I go out 2. 2 cubed is 8. I double that, I get 16. So let me just move this graph for a second. And let me see if I can get up to 16. So 2 cubed is 8, double that 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's going to be off my graph. And then I come to the left one, -1. -1 cubed is -1, times it by a 2. I get -2. And then again, we can see if we can, sorry, do that. So 2, that would be 2 cubed is 8, times by -2, -16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And it looks like it's going to be off. So then I am going to connect this. And remember, it's almost like an open down, and it changes to an open up. Okay, on this next one, this is a square root. This square root is going to be starting at, let me just get rid of that for a second. Sorry, it's reading. I've got a mouse and a stylus going here, and it's so this is going to be at 1 comma -3. So I'm going to go to 1 comma -3, 1 comma -3, and then this doesn't have a stretch in front, so this is a regular square root. So I go out 1, square root of 1 is 1. The next nice square is 4, so I'm going to go out 4, 1, 2, 3, 4. Square root of 4 is 2. I'm going to go out 9. So that's 4, 5, 6, 7, 8, 9. Square root of 9 is 3. 1, 2, 3. 10, 11, 12, 13, 14, 15, 16. Square root of 16 is 4. 1, 2, 3, 4. So I'm always going from here out, whatever square root of 1, square root of 4, square root of 9, square root of 16 is 4. And there's my graph. Okay, this one, we have a locator point at 2 comma -3. And we have we're going to have a y equal -3 for my asymptote. So let me so let's see, y equal -3. Let me draw that in. And now if I was going to go to 2 comma -3, so 2 -3, which is right here, this is where I'm going to go 2 to the 0, which is 1. Now I'm going to double that 2, double that 4, so 2, 3, 4, double that 8, so that's 4, 5, 6, 7, 8, double that 16, so 9, 10, 11, 12, 13, 14, 15, 16, and then I'm going to draw. Let me get this a little thinner. And there's my graph. This one is going to be a reciprocal function. So x equal -3 is going to be an asymptote. And y equals 7 is going to be an asymptote. So let me draw in y equals 7. Oops. Okay. So y equals 7 is going to be here. X equal -3. And this point right here is going to be kind of, that's my new start. That's my new origin, if I want to think about it that way. So let me get my graph. And because this is a 1, I'm from here going to go over 1, up 1, over 1, down 1. Okay. And that's going to be where I'm going to be plotting. So I've got one here and here. And then I'm drawing my reciprocal function. And that's the end of this. And again, this is just to get you guys to practice doing these graphs until they become second nature to you. And you can just look at it and you know what type of graph shape it should be. You know if it should have an asymptote or two asymptotes. You know where the important locator points are, and you can plot it.